All right, guys, we're moving on. And actually, we're going to split this section into two pieces.
Yep, two big concepts here, so we want to kind of give you guys a day on each.
Yeah, we want to slow down a little bit here and make sure that we take some time to be sure you catch this. And so there are two different things here, but we're going to do one of them today and one of them tomorrow. But we're talking about midpoint and distance formulas. And you've seen both of these,
yep.
Right? We also do midpoint in Algebra 1?
A little bit.
A little bit, okay. So you've seen both of these. I'm not sure how much time you've spent on them, but you've seen them both. And so, we're going to run with that. So again, another definition, because we're building our vocabulary here. One of them, the definition is midpoint. And it is the point that is in the exact middle, therefore mid, of the segment. Now, this is different than between.
Right. Between can be anywhere.
In fact, you were talking about it in between. Some people confuse it with this.
Right,
that
exactly.
It has to be exactly in between. But that's what this is. This is the middle point, the midpoint. And so it has to be exactly the same distance between the two endpoints of the segment. And so basically it cuts it into two equal pieces.
Right.
The two other segments and end up being congruent to each other.
And midpoint is, we're going to see that a lot, and it's kind of a big deal in geometry.
Oh yeah, we use it over and over and over again.
Yep.
Yeah. And it sets up all kinds of equations that we can do.
Yep.
And so again, our mix of algebra and geometry. And so again, they always have to be collinear though. And the two segments, the two endpoints that we're talking about have to be on a segment already, or collinear on a segment for us to get the midpoint. So.
And just like when we did the segment addition postulate, we always said part plus part equals whole.
Right.
Well, now you can apply that to this. It's just part equals part.
Both parts are the same.
Yeah. Part equals part.
Yeah. So, and these are very similar terms, and so you have to make sure you understand the difference between them. Yeah. And so a bisector is some other thing.
Yep.
A segment, a line, a ray that hits that midpoint, that cuts the segment into two equal pieces. And so a bisector is some other device, and typically it's those three, right? Am I thinking about that right? Segment, ray, or line that cuts a segment exactly in half, two equal pieces. And so a bisector is something else that cuts it, and a midpoint is the middle point. Okay?
A bisector, guys, it's the thing cutting it in two.
Right.
You know, and remember, bi means two,
Yep.
So it's the thing cutting it in two.
That's true. Yeah, we need to look at the definition of that word itself. Bi means two, like bicycle is two wheels.
Yep.
Sect means to cut, like you dissect a frog or whatever in biology or whatever. And so that means to cut up. And so a bisector cuts things in two equal halves.
Yep.
All right. So when we're given this fact that AM is 17, the whole thing, the whole segment here is 17 in length, then that means that we can find each of the two pieces here. And so if we're asked to find AR, then AR would be 8.5 because it's half of the 17 total, because we know that R is the midpoint. And so the two halves are the same. All right? So we're going back to bisect for whatever reason.
Yep. So bisect is cut into two equal pieces. So that's just another definition of it. You know, I mean, that's what it does. It cuts it into two equal pieces. And so a segment bisector, it could be a segment, a line, a ray, a plane that intersects a segment at its midpoint, creating two congruent segments. So, you know, basically it just says that any of those things could cut it in half, and it creates that midpoint where those segments become congruent.
Yeah, I guess I didn't think of a plane earlier, but that doesn't happen very often.
No, not
It's
very
kind of
often.
weird.
Yeah.
So, yeah. Oh, so here's a good example.
Yep.
Because we don't see this a ton, but we need to understand it could be anything that bisects that. So if we have segment HM, and we are told, this is critical, we're told that ray JI bisects it, we have to know that information, that it bisects the segment. Then if they give us one of those pieces, well, we can do our hash marks again,
Yep.
because the hash marks indicate that we show that it cuts it in two equal pieces. Then we can find the other piece based on them giving us one of them. So if they tell us that one of them is 12, the other piece has to be 12.
And 8's just the JI, guys, the length of JI is just a distractor here.
Mm-hmm.
You know, you got to be careful. Don't say 4, you know, because JI is the bisector, not the thing being bisected. And so you got to be really careful that you don't say IM is 4, you know, or 16 or something like that. You just be careful there, okay?
Yeah,
you got to know.
we don't care about the bisector.
No, it's just there to kind of confuse you. So make sure you don't get the thing doing the cutting mixed up with the thing being cut.
Yeah, yeah. So IM here is 12.
Yep.
Because the other piece is 12.
Part equals
So,
part.
right. We're going to do a similar thing here, right?
And we want you. Is this the one we want them to try out tonight?
No, I think we have one more, don't we?
Okay.
Yeah, this is one more example. Just putting this onto a number line. Oh, we're integrating some algebra here.
Yep. Yep.
And so if point M is the midpoint of the full segment VW, okay, then they want us to find the length of VM. Okay. Well, how can we do that if we don't even know how long the whole thing is?
Ooh, I don't know. You can just say part equals part.
There we go. Part equals part. So we're going to set those equal to each other. So VM has to equal MW because that's what it means to have congruent segments from the midpoint. And so we can plug those values in that we know. So VM is 4x minus 1. MW is 3x plus 3. And so there's our algebraic equation that we can go through and solve now. So we remove variables, subtract 3x from both sides. We get 1x and add 1 to both sides. And so we get x is equal to 4. So the answer is 4.
No, this is where you got to be really, really careful. And this is a new shift from Algebra 1, guys, to where in Algebra 1 we told you, okay, find x. All right, we're done. Well, not here, because x equals 4 is not the distance of VM. X equals 4 is just the variable.
Right.
And so you have got, this is one of the critical areas in our class, guys, is you've got to recognize when they're asking you for x or when they're asking you for a distance of a segment or whatever it happens to be. And so you got to take that x and you got to do what, Mr. Scritch?
Plug it in.
Plug it in. So you got to be really, really careful here, guys, to really pay attention to what's being asked, the semantics of the question here.
Yep.
So I got to take that x equals 4 and I got to substitute it back in. Now, you know, it doesn't matter which one you substitute it in, right? Because VM is the same as MW. So if you like the equation of MW better, plug it into 3x plus 3. Or if you like the equation of VM better, plug it into 4x minus 1. It doesn't really matter, because if you were to test it, you're going to get the same answer both times, because part equals part, because it's that midpoint.
But that's based on your knowledge of midpoint, because
Yep.
they're asking you for VM. So if this was some other question, you would have to plug into VM specifically to
Right.
find the answer. But we know these are both the same.
Right.
So 3x plus 3 might be a little easier to plug into. So we plug in there, and they're plugging into VM specifically because that's what they asked for. And the answer is 15. 4 times 4 is 16, minus 1 is 15.
Now, what if they asked us, what is the length of VW? What could you do from there?
That'd be tricky. You could understand again the fact that we're talking about a bisector and the two pieces are equal. And so just as we were saying, VM is 15 from this. MW would also be 15 because 3 times 4 is 12 plus 3 is 15. So we just add them together and get
There you go.
30 for the total.
The part
But
plus
that's
the part equals 30.
But that's a definite thing that they will ask you.
Yep.
So you have to be very careful of what piece they're asking for in order to answer the question correctly.
Yep.
So we're gonna have you do, well, we're gonna do this one example, and then this slide we're gonna have you answer a question to bring into class again tomorrow. And so this one's kind of a weird number here.
Yeah.
And so this is gonna freak some of you out because it has fractions.
No.
Ah! And so we're gonna have to just break this down, and you need to have a little bit of number sense here to be able to do that. And so if they're asking us for, we should have had the question come in here, but they're asking us for the two pieces of this segment. And they tell us that we know that I is the midpoint, and we have to be able to calculate the length of LI and the length of IT. And so we have to take half of 18 and 3/8 because LT is the whole thing, and so we have to take half of that. Well, part of that's easy.
Yeah.
Half of 18 is 9.
Yep.
Right? And so we go 18 times 1/2.
Yep.
Which is the same thing as dividing by 2.
Right.
But we have to be careful with it. It might be better to multiply it by 1/2 because of the fractional part here. And so, so the 3/8 part here is similar.
Right. And just remember, guys, that when you deal with fractions, there is really no division of fractions. Remember, we always kind of change it to, you know, we change the division to multiplication, and then we flip the second one over. Well, if you were dividing by 2, it's really in essence multiplying by 1/2.
Same thing.
And so, because you got to remember that, you know, that the numbers get big, the denominators get bigger as they get smaller.
As the number gets smaller.
Yeah, and so it's just kind of a little thing that, you know, some of you guys are going to struggle with. Other of you will get through this no problem. But, you know, cutting 18 is really in half is really easy, like Mr. Scritchfield said. We know that's 9. But then when you cut 3/8 in half, it's actually going to look like it's bigger, but it's smaller.
Right. Right.
It's,
Because if we multiply that,
yeah.
we're going to go 3 times 1 on top is
Yep.
3. 8 times 2 on the bottom is 16. And so the answer is 3/16 for the
Right.
fractional part.
Yep.
And so we're going to get the 9 and the 3/16 combined together to be half of this entire segment. And so when they're asking us for the two pieces, they're both going to be the same because we have a midpoint, and they're both going to end up being 9 and 3/16. Okay, so some tough numbers there, but the concept you need to understand of midpoint is half and half again. All right, so we're going to have another diagram here, and we have 3 questions, I believe it is. Yep. 3 questions here for you to answer. And so pause the video right here and go through and answer those 3 questions right there. Okay, and again, be careful what they're asking you for. Okay, make sure you're getting the right pieces out of the diagram. Now we're moving it to a coordinate plane.
Yep.
So we're going to the formula we used in Algebra 1.
Yep.
Right?
Yep.
Okay.
So now we get to the midpoint formula here, guys. And this is where it just gets it's going to look scary, but it's not. You know, and so
it's just a formula.
It's just a formula.
You just
and
plug in.
You know what an X is, you know what a Y is, and you know where they're at. And so it's just a matter of, you know, if they want the midpoint formula, you know, or what you're trying to find here is you're just trying to find the middle of a segment, and so you're going to have 2 X's and you're going to have 2 Y's, and then you're just going to kind of use those in conjunction with one another to find the middle point on a graph. So notice that it's in parentheses, you know, meaning that it's a point somewhere. And so when you finish this, you're going to have that middle point. And once you see it visually, it'll make more sense. But you need to write that formula down. So
now notice it says averages there in that definition. Well, how do you find the average of 2 numbers?
Yep. Add them together and divide by the number you're doing.
Which is 2.
Which is 2 here.
So that's why the 2's are on the bottom, because we're adding together 2 X's and 2 Y's, because again, we have 2 points on a coordinate system. So we add the X's, we add the Y's, we divide both of them by 2, that's finding the average, and that's the midpoint.
Yep.
It's a pretty basic formula.
Yeah, it just looks scary because it's got all these X's and Y's in there and division by 2.
Don't let the subscripts throw you off. Again, that just distinguishes between one of the X's and the other X, one of the Y's and the other Y.
Yep.
And so we got to know the difference between them.
So if we wanted to find the midpoint for S and T, so if you could visualize a line on a graph from S over to T, we want to find that point in the middle. So basically, guys, it's just a matter of finding the averages. So we know that for the X's, the X value of S is 1 and the X value of T is 7. So I just go 7 plus 1 is 8, divide that by 2, and I know that my middle X is 4, and then I do the same thing for the Y's. S is Y is 2, T is Y is 4, so 2 plus 4 is 6. 6 divided by 2 is 3, and you'll kind of see it laid out right here. And so there's my middle of 4, 3.
Okay.
I mean, it's kind of hard to not see it visually, but just remember it's the averages of the X and the averages of the Y's, and you just add them together and divide by 2.
Yeah,
pretty much.
We're just substituting.
Yeah.
Taking that 1, putting it into the X, taking that 7, put it into the other X, add them up, that's 8 divided by 2. That's where the 4 came from. The 2 in the place of one of the Y's, the 4 in place of the other Y. 2 plus 4 is 6, divided by 2 is 3.
Yep.
So, all right. And we'll do more of them in class, obviously. Same thing, just visual.
Yep.
To where we have a graph.
Yep.
Right, so the endpoints are 1, -3 for R, 4, 2 for S. So this one might make a little bit more sense for you because we have a picture going on. And they made it real clear that in the graph itself, in the picture, the X's are blue and the Y's are red.
Right.
And so we're just trying to, again, pull those apart from each other. So they want you to find the coordinates of point M. And so we're going to do the same thing. We're going to plug into the midpoint formula. So we're going to take the X of the R, we're going to take the X of the S, and it doesn't matter what order you do them in because we're just adding them. So 1 plus 4 divided by 2. We're going to take the -3, the Y of the R point, and the 2, the Y of the S point. Add those 2 together. Now notice one of them is negative. You got to be careful there. And divide by 2. So we're going to end up with 5 over 2 and -1 over 2. And so the midpoint, the coordinates of that M point, the midpoint are 5 halves, or 2.5, and a -1/2. Notice that M is kind of in the middle of a box, and so it does have halves in it. All right?
Now this one right here is kind of and this is mostly the reason why we split this into 2 days is because this is a little bit tricky because on this, you know, this says find the end point. Well, oh boy, here we go. they're giving us the midpoint this time, and you got to find the other end. So we know from here to here, but where's this piece over here? And so this is where this gets just to be a little bit tricky because the setup's a little bit different. So when you go to work this out, you'll see the setup. It'll be more easy to explain once we look at the setup. But
So this is one we wanted them to look at and try to answer and look at in class, wasn't it?
yeah, sure, we could do
And
that.
so if we they're wanting you to find the x and the y of this end point down here now, not the middle point, but the end point. And so we just want you to try this. You might get stuck on this, and that's fine, because this is the hardest question that comes up with the midpoint formula.
Yeah, and I'm
not trying to find the midpoint, but trying to find one of the endpoints.
And I think in chapter 1, it's probably the toughest thing to do because it's just kind of abstract.
Yeah. So try this, but we'll do this example specifically in class at the beginning of the period tomorrow. So. And that's where we want to wrap it up with the first part of section 3. We're going to spend 2 days on this section, and so we're going to end it here and go from there. So,
did you want to show them the other couple steps there?
We can.
Oops.
It's going to go through this process, though.
Yeah.
So we'll show you that step right there. That gives you a hint on how to do the rest of it, and that's a major hint actually.
Yeah.
And go from there.
Remember, you got to find X and Y, so use that hint to kind of help you set up Y as well.
Yeah. Okay. We'll see you guys in class tomorrow.
All right. Good luck.